Good morning, students. Today we are going to learn about coordination complexes which are formed by the D block elements. It is the main characteristic property of the and the important characteristic property of D block elements. So, what are the complex compounds? How they can be produced, and what are the physical and chemical properties of these coordination complexes? Before going to the coordination complexes, what are the main concepts or which are involved in these coordination complexes? First one is the differences between double salt and coordination compound. Double salt and a coordination compound. And second one is the physical and chemical properties are described by the Werner. So, Werner's theory, that is the important one. And third one is the terms or the definitions which are used in this coordination complexes. Main definitions which are used in this coordination complexes. So, we will study about these three topics mainly. So, first of all, what is a coordination complex and what is the main difference between a salt and double salt and a coordination compound? Generally, we will know the salt, which is a salt. The definition for the salt is an acid and a base reacts to give salt and water. That is the general definition. So, for example, if we take a salt, that is NaCl and KBr, potassium bromide. NaCl, it is hydrolyzed. That means it is when it reacts with water, it will give Na plus and then Cl minus ions. Whereas KBr, potassium iodide, when it dissolves in water, it will give K plus and then Br minus ions. That means the salt which is these salts are which is dissociated into their constituent ions, dissociate into its constituent ions. So it is called as the hydrolysis. This process is called as the hydrolysis. So by the hydrolysis of a salt, we will get the individual ions which are present in that salt. That is the hydrolysis. And double salt. What is a double salt? These are the single salts, that is only NaCl, that it will give only Na plus and then Cl minus. KBr, it will give potassium bromide, it will give potassium salts and then bromide ions. So with double salt means it is a combination of two salts. For example, it is KCl, MgCl2, 6H2O. KCl, MgCl2, 6H2O. It is the main ore of the magnesium metal. This is the main ore of the magnesium metal. So this salt on hydrolysis, it will give potassium ions, 3 chloride ions and then magnesium ions. So potassium ions, magnesium ions and then chloride ions. It will give the potassium ions, chloride ions and then the magnesium ions. So it is called as the double salt. It is called as the double salt. So simultaneously another double salt, that is FeSO4 NH4 twice SO4, ferrous ammonium sulfate. It is called as the ferrous ammonium sulfate. So on hydrolysis it will give Fe2 plus ions and then 2 SO4 minus 2 minus ions and then 2 NH4 plus ions. So it will give it will participate, the whole salt will participate in the hydrolysis process to give its constituent ions like iron ion, sulfate ion and then ammonium ion. So these type of salts are called as the double salts. These are called as the double salts. So what is the difference between a coordination compound and a double salt? Next we will go to the differences. Differences between coordination compound and a double salt. In coordination complexes or coordination compounds, for example, if you take COCl3 6NH3, COCl3 6NH3, it is called as the hexaamine cobalt 3 chloride. Cobalt 3 chloride. So that is the complex. So in this complex, it can be on hydrolysis, it can dissociated into two types of constituent ions. One is the metal complex CONH3 6 times 3 plus ion, and another one is the 3Cl minus ions. So it will give only 4 ions. One is the complex ion. This one is the complex ion. Whereas in double salts, we do not come across any complex ion. It will give only the individual ions. So that is the main difference between the coordination complexes and the double salt. That means in a coordination complex on hydrolysis, it will give a one complex ion and another constituent ions. These constituent ions, which are called as the counter ions, these ions are called as the counter ions. That is the main difference between a coordination compound and a double salt. So the properties of coordination complexes are described by a scientist called as the Alfred Werner. Alfred Werner. He described the whole properties and the preparation of the coordination complexes. So named as the Werner's theory. It is the most important one, and the Werner's theory of coordination complexes. Very, very important also for the board examinations also. So what is Werner's theory? How it can be defined and how it can be explained. So first one is in Werner's theory is about the coordination complexes. It is about coordination complexes. So from this coordination complexes, he explained it is the here in coordination complexes, central metal atom is present. It is a d block element. It is one constant central metal atom which is linked with the which is in coordinate covalent bond which is participated with the coordinate covalent bond with the electron donors, electron pair donors, which is involved in the electron paired donors. Electron pair donors. These are, in other words, it is also called as the ligands, and then ions, and then negative ions. So there are three types of bonds are present in between the metal and the metal complex and the negative ions. The metal atom or the metal ion, which involves in the both ionic bonding as well as in the coordinate covalent bonding. So it will give coordinate covalent bond with the electron pair donors, which are in terms called as the ligand. They are called as the ligands, and the metal atom is participated in ionic bond with the negative ions. So in coordination complexes, there are the two types of complexes here. And the next one is the The physical and chemical properties of the coordination complexes are explained by this Werner theory. So next one is the he proposed the theory by explaining or by observing the physical and chemical properties of coordination complexes. Physical and chemical properties of coordination complexes. And next one, the central metal atom, that means the metal ion or the atom which is involved in the coordinate covalent bond. Here we are taking a simple example, CONH3 6 times and then Cl, that is Cl minus. So in this ion, in this hexammine cobalt 3 ion, cobalt is the central metal atom. Cobalt is the central metal atom which is involved in the coordinate covalent bond with ammonia as well as the ionic bond with Cl minus ions. So from this example, he explained the central metal atom shows two types of valencies. Metal atom or ion shows two types of valencies. What are those valencies? They are ionic valency and coordinate covalent valency. Ionic valency and the coordinate covalent valency. So what is ionic valency and what is the coordinate covalent valency? In ionic valency, ionic valency it is nothing but the oxidation state of an element. Oxidation state of the metal ion or atom. Metal atom or ion. That is the ionic valency. Coordinate valency. This coordinate valency is it is exhibited by the metal atom which involves in the coordination covalent bond. Coordination covalent bond with the electron pair donors. The electron pair donors. So these are the two types of valencies exhibited by the central metal atom. First one is ionic valency and second one is the coordinate covalent valency. So this ionic valency is also called as the primary valency. It is also called as primary valency. Primary is shown as the one superscript of 0. So and next one, coordinate valency, it is called as the secondary valency. Coordinate valency is also called as the secondary valency. So primary valency and then secondary valency. So each metal atom exhibits two types of valencies, that is primary valency and second one is the secondary valency. In primary valency is ionic valency and secondary valency is also called as the coordinate covalent valency. In primary valency, it is satisfied by the negative ions. It is satisfied by the negative ions. Whereas in secondary valency, it is satisfied by the neutral atoms, negative ions, and positive ions also. Two ions and then positive ions. So the spatial arrangement of the spatial arrangement of coordination atoms or molecules in terms, that means they are the electron pair donors or ligands. Electron pair donors are the ligands. So these ligands, the special arrangement of ligands around the metal atom, is called as coordination polyhedra. So depending on the coordination numbers, the structures will also depend on the structure of coordination complexes will also depend on the number of coordinations. That means number of ligands or the coordination number. That means the number of ligands which are surrounded by the central metal atom is called as the coordination number. Coordination number, that means the number of ligands surrounded by the central atom is called as the coordination number. It is called as the coordination number. So the coordination numbers are, there are two types. First one is 4. The coordination number is 4. If the coordination number is 4, the structure will be tetrahedral or square planar. Tetrahedral or the square planar. If it is 6, coordination number is 6, it is octahedral. Structure is octahedral. So these are the main important terms, that is coordination number, the number of ligands surrounded by the central atom or which are involved in the special arrangement of the central metal atom. So next one is the For example, he explained these coordination complexes by taking a simple example that we have already known, COCl3 6NH3. So here the NH3, these are the ligands. NH3 is the electron pair donor, it is called as the ligand. So there are 6 ammonia molecules act as ligands, and Cl3, it is the negative ions. So we will write the complex structure as CO. CO is the central metal atom, cobalt is central metal atom, and these ligands are shown in the small brackets with its number CONH3. So here the remind is the Cl3. The Cl3 will be outer side of the square bracket. So this the formula which is written in between the square brackets, it is called as the coordination metal atom. So it is called as the coordination complex. It is the metal complex as the metal coordinate complex. Metal coordination complex. And the ions which are written outer side of the square bracket, they are called as the counter ions. These are called as counter ions. So we will write this structure COCl3 NH3 6 times Cl3. So the structure will be, that means in coordination complex, the molecules which are present in the small brackets, they are known to be involved in the coordination bond. So in coordination bond, ionic valency is shown by the dotted line. Ionic valency is shown by the dotted line, and a straight line is shown by the straight line or the hard line. It is denoted as secondary valency, that is coordinate valency. Primary valency is shown by the dotted line, and secondary valency is shown by the straight line. So ammonia molecules involved in the secondary valency, whereas chlorine involved in the ionic valency as well as the primary valency. So we will write this structure, that is CO is the central metal atom and its coordination number is 6. So 6 ammonias are involved. 6 ammonias are written as a straight line. Six ammonias are involved in the straight line. So which are remaining? Chlorine atoms. 3 chloride ions are remained. These 3 chloride ions are written by the dotted line. They are shown in by the dotted line because they are involved in the which bond? They are involved in the ionic bond. So that is the COCl3 6NH3 structure. Here, if we treat this 1 mole of COCl3 NH3, 1 mole of COCl3 NH3 with AgNO3 silver nitrate, it gives 3 moles of AgCl precipitate. Why it consumes 3 moles of AgNO3 and gives 3 moles of AgCl? Because here there are 3 chloride ions which are specially oriented around the central metal atom. So because of these 3 chloride ions which are involved in the ionic bond, they will release 3 ions in non-hydrolysis. So they will readily combine with the 3 moles of silver nitrate to give 3 moles of AgCl. So another compound, we will go for the another compound, that is COCl3 5NH3. COCl3 5NH3. That means there are 5 ammonia molecules are present around the cobalt atom. NH3 5 ammonia. So how many chlorides are there? 3 chlorine atoms are present. These 3 chlorines are denoted with the dotted line. Okay, here the coordination number of this COCl3 5NH3, these complexes is always 6. So here only 5 coordinate covalent bonds are present, 5 ammonias. Another coordinate covalent bond will be involved by the chloride ion, one chloride ion which involves both ionic valency, which satisfies both ionic valency as well as the coordination valency. So it cannot ionize, it cannot easily ionize, So only 2 chlorides, they will involve in the reaction of silver nitrate. So it will readily gives the 2 moles of AgCl, because one of the chlorine atom which involves both ionic valency as well as the secondary valency. So next one is the another compound, COCl3 4NH3. COCl3 4NH3. That means CO is the central atom and 4NH3 atoms are present. Here there are the 3 chloride ions. They are involved in the ionic bonding. So when it reacts with AgNO3, it will give 1 mole of AgCl. 1 mole of AgCl. Why? Because 2 chloride ions involved in the coordinate covalent bond also, because the coordination number is for this compound is 6. So 2 of the chloride ions involve both ionic valency as well as the coordinate valency. So it will give only one free chloride ion is there, so it will readily use the AgCl precipitate. And another one is the COCl3 3NH3. It has only 3 ammonia molecules, NH3 and then NH3. So 3 chloride ions are also present. 3 chloride ions. So in these 3 NH3, the coordination number is 6. So all these 3 chloride ions will also involve in the coordinate covalent valency. So there is no ionization takes place and there is no reaction with the AgNO3. There is no reaction with AgNO3 and there is no AgCl precipitation. So by explaining these examples, Werner explained the coordination complexes. And next one is the important terms in the coordination complexes. What are the important terms? First one is ligand. Very important one, that is ligand. Ligand means first one is a ligand. Ligand means electron pair donors. So in other words, they are also called as the Lewis bases. They are the Lewis bases. Electron pair donors are the Lewis bases. And second one is the coordination entity. The spatial arrangement of ligands around the central metal atom. The spatial arrangement of the ligands around the central metal atom is called as the coordination entity. And next, third one is the central metal atom. The central metal atom we have already explained in the COCl3 6NH3. Central metal atom means the ligands which are attached to which metal atom, it is called as the central metal atom. And next one, central metal atom is generally referred to as the Lewis acid. Because they accepts electron pairs, so it is called as the Lewis acid. And next one about the ligands, types of ligands. Important one is the types of ligands. So first one is the unidentate ligand. The ligand which contains only one donor atom. It is called as the unidentate ligand. For example, Cl minus, Br minus, OH minus. And these are the unidentate ligands. And next one is the bidentate ligand. Bi means two. So if two donor atoms are present, two donor atoms are present, it is called as the bidentate ligand. For example, ethylene diamine, En, it is easily denoted as the En, ethylene diamine. Its structure is CH2 NH2 and again CH2 NH2. Here the two amino groups, the two amine groups, NH2 groups, these two amine groups which are involved in the coordination bonding of the central metal atom, coordination bond with the central metal atom, so it is called as the bidentate ligand. That means two donor atoms are present, so both are involved in the coordination covalent bond with the central metal atom, so it is called as the bidentate ligand. And next one is oxalate ion, C2O4 2 minus. Metal ion involves with the C double bond O, O minus, C double bond O, sorry, metal ion Mn plus O, C double bond O, C double bond O. So these are the bidentate ligands. If more than two donor atoms are present, they are called as the polydentate ligands. Polydentate ligands, that means more than two donor atoms. In the two donor atoms, they bond with the central metal atom to give a ring-like structure. Ring-like structure. They are called as the chelating ligand. Chelating ligand is a bidentate ligand or polydentate ligand which involves in the ring formation of the ring-like structure with the metal atom. The M plus ion or the metal atom, it is called as the chelating ligand. For example, ethylene diamine, CH2NH2 and CH2NH2. Here there are two donor atoms. These two donor atoms are involved with the metal ion, so it will give a ring-like structure. So it is called as the, so this one is called as the chelating ligand. And another example is the EDTA, that is ethylene diamine tetraacetic acid. It is also a chelating ligand. And next one is the important one, that is ambident ligand. It is also a bidentate ligand. It is also a bidentate ligand with two donor atoms. Two donor atoms. So these donor atoms will attach with the central metal atom, either the side of the donor atom. The ligand attaches with the central metal atom, either side of the donor atom. That means, for example, NO2. Here it is a structure for NO2, that is N double bond O, single bond O, and bond O, single bond O. Here this ligand, this nitro ligand will attach with the metal atom, either with the nitrogen atom or with the oxygen atom, either with nitrogen or with the oxygen, either with oxygen or with the nitrogen. So it is called as nitrito O. Nitrito NO2 group is called as nitrito. It is attached with oxygen to the central metal atom, so it is nitrito O. Here it is attached with the nitrogen, so it is called as the nitrito N. It is called as the nitrito N. And another examples are cyanide, Cn minus. Cn minus. If the central metal atom attached to the carbon, it is called as the cyano. If the metal atom attached with nitrogen in the cyanide group, it is called as the isocyano. Simultaneously, SCN minus, it is thiocyanate. If it is attached thiocyanate, S attached with the metal atom, it is called as thiocyanate. When the metal atom attached with the NCS, it is called as the isothiocyanate or thiocyanate N or thiocyanate S. So these are the called as the ambident ligands. These are called as the ambident ligands. And the next one is the coordination sphere. The groups coordination sphere are called as the coordination atoms or the ligands which are attached to the central metal atom is called as the coordination sphere. For example, FeCN6, K4 FeCN6. Here K4 are the counter ions, 4 potassium ions, and this FeCN6 is called as the coordination sphere. And next one is the oxidation number of the central atom. Oxidation number means the number of electrons which are lost or which are involved in the ionic bonding. It is called as the oxidation number. And next important one is the homoleptic and heteroleptic complexes. What are homoleptic and heteroleptic complexes? Homoleptic means if the central metal atom attached to one kind of ligands, only one kind of ligands, it is called as the homoleptic. For example, CO, Cl3, 6NH3. Here only ammonia atoms will attach to the coordination, will attach it to the cobalt, so it is called as the homoleptic complex. Whereas if the number of different types of two more kind attached to two or more different kinds of ligands, it is called as the heteroleptic. It is called as the heteroleptic complex. For example, CO, NH3 4 times, Cl2, Cl2 plus, it is called as the heteroleptic complexes. So that is about the important terms in the coordination complexes as the Werner's theory. If you have any doubts, you will ask your teacher.